Okay, so this is starting at the absolute basics of 3D computer graphics. So I'll run over some key concepts, but if you already know about vertices, triangles, and polygons and so on, feel free to fast forward to the point where we start writing our code. Alright, so the way in which real-world objects in 3D computer graphics have always been created almost exclusively is to create simplified models of these objects using points at the corners and triangles between those points, and we call this model of the object a mesh. Points at the corners, triangles between the points. We call it a mesh because it looks similar to something made from, for example, a wire mesh. And so then on each triangle that is part of the mesh, we finally map a piece of a surface texture of that object, and that's the simple version of how all 3D computer graphics are done. From Quake, which was the first truly 3D computer game, awesome game, to Minecraft, pretty much any 3D looking game you can think of. Fortnite, and movies, Toy Story, the Avengers movies, even commercials and designs that people do for cars or just about anything 3D in companies these days. Alright, so what we're going to do is to create a very simple object using code, which is just one flat square consisting of two triangles. But once you can do that, you can extend it to create anything that you like in code. Alright, now there's a bit of elementary school maths involved here. So if you want a bit of a refresher on the coordinates of points, there's a link to a Khan Academy video in the comments. So maybe pause this video and go take a look at that first if you need to. Okay, so as we said, we have some points, also known as vertices. And you can imagine some lines between these points. Well, we don't need to imagine, I've made them for you, to form the three sides of a triangle. But often in 3D model, we don't need to store the lines, just the vertices and the triangles themselves. So I'll take those lines away. So what we need to do to make our basic mesh of a square is to create four vertices. I'll add the fourth one and use those four vertices to make two triangles. So let's jump. Okay, so I've created an empty project here, and I've just created a few basic folders to keep a little organized, like code for our scripts, textures, materials, prefabs. Okay, so let's go into code and right click and create a new C# script, and we'll just call that my mesh. Alright, so here we are in the new script, and the first thing I'm going to want to do, in fact I've already started it there, is to create an array to hold those four vertices. Alright, so we've got public vector 3. There is a bit of assumed knowledge in this video about C# and Unity scripting, but if you're not 100% sure on things like vector 3s, arrays, indices and so on, there's a link in the description to Bracky's playlist on how to program in C#. So feel free to check that out first if you need to. Alright, so let's create our vertex array. So public vector 3 array vertices equals new vector 3, and we need 4 of those. Okay. And the next thing to do is to create an array to hold the two triangles. So the way that Unity stores triangles in a mesh is to keep an array of indices into this vertex array that we just created. So what does that mean exactly? So the way we're going to make our triangles, the first one we're going to start at vertex 0, go up to 2, and across to 3. And that will define this first triangle. If we do that, 0 to 2 to 3, then we're moving in a clockwise direction around the triangle, and then the triangle we create will face the front. If we went anti-clockwise, for example 0 to 3 to 2, we'll create a triangle and the computer will display that as facing the other way, so we wouldn't see it from where we are, and we don't want that. Alright, and I've made an example of that over here in Unity so that if we're going clockwise, you'll be able to see our triangle. If you're going anti-clockwise, then the computer will think that it's facing that way, away from us, and you won't be able to see that. Where's my quad? Okay, there's actually one here. It looks like a square, but it's actually made of two triangles. If we go into wireframe mode, you can actually see the two triangles there. Okay, now because this one, these two triangles have the other winding, they're facing away, so if I click off of it, you can't even see them from this side. From the other side you can. Alright, that's why we have to be careful about the winding. Okay, so keeping in mind that we want clockwise winding, if we want a front-facing triangle, our first three vertex indices are going to be 0, 2, and 3. And it doesn't matter where we start our trio of indices, we'll still get the same triangle. So in our script, if we instead of writing 0, 2, 3, if we started at 2 and went 2, 3, 0, we're still going to get the same triangle and it's still going to point towards us. It will still create exactly the same front-facing triangle. Okay, so let's create our triangle array, and because it just contains indices, it can just be an array of integers. And we need the indices of 3 vertices for each triangle, and we have 2 triangles, so that's 6 indices we're going to need. So public int array call that triangles. Fingers are a bit cold here, so it's a bit hard to type. Triangles equals new int, and as we said, we want 6 of those. Okay. Now, up until now, we've just considered our triangles on the flat plane of the screen. So that's the XY plane. But in Unity, our triangles will exist in 3D space. So we have to consider the Z coordinate too, or Z coordinate if you're American. But in our case, we're going to leave all our points on the XY plane. So the Z coordinate will simply be 0. Okay, I think in Unity, yep, I've got an example of what I'm talking about. So here's the axes down here, and the red is X, so the XY plane is this plane, and the blue is the Z going into the distance that way. So our points are just going to be on the XY plane and 0 Z coordinate. Alright, so let's jump into the start method and we'll do some initialization. So vertices 0. Equals new, and they're going to be back to 3s. And we're going to go 0, 0, 0 for the first one. Let's take a look at why that is. Alright, so first one's got x coordinate of 0. If we're calling this point here the origin, imagine the axis going x-axis from the origin along here, y-axis going up. So 0, 0 for the x and y, and because we said all the z's are going to be 0, the first point is 0, 0, 0. Next one. Alright, so challenge. What's the next one going to be?
A few moments later.
Okay, the next one we want to go across to vertex 1 or point 1. So the x coordinate is 1. Because it's down here, the y is 0, and all the z's are 0. So like we said, the x is 1, the y is 0, and the z is 0. All good. Oop, got to change that to vertex 1. Okay. Next one, vertex 2 is up here. So the x is 0, x-axis, the y is 1, and the z is 0. So we have 0, 1, and 0. I've just decided that the length of these sides is going to be 1, just to make it simple. But of course that can be changed. Okay, the last vertex is number 3 over here, and that's at x is 1, y is 1, z is 0. X is 1, y is 1, z is 0. Alright, so they're all done. And now for our triangles. So we say triangles equals, and we can initialize the array with curly braces, and first one was going to be 0, 2, 3, if you remember. 0, 2, 3. So the way this triangles array works is, it's just the indices into the vertex array, and then we've got 3 of them to make our first triangle, and then when we want to start our second triangle, we'll just continue on from there. So the second one we said was going to be, first one was 0, 2, 3. Next one we'll also start down at 0 and go clockwise. So we go 0, 3, 1. Alright, 0, 3, 1, and that's it. Because we've only got 2 triangles for our simple mesh. Okay, and that's going to make 2 triangles that are both facing us, because we've made sure that they are clockwise winding, and they won't be facing backwards. Okay, so Unity has a mesh class to hold our mesh data, and the mesh class lives inside a helper class called mesh filter for historical reasons. It's not really a filter, but anyway, so we'll add a mesh filter component to this game object first. Okay, so we want to go game object to add component. Why is it not giving me add component? Maybe it's not a static method. Game object dot add component, and it wants to be actually add component mesh filter. I think this is the syntax, and we'll store that, a reference to that, as var mesh filter. Okay, and we also want to be able to see our mesh, so let's add a mesh renderer too. Var mesh renderer equals game object dot add component. Add component. Might turn the heater on so that my fingers can actually let me type properly. What am I doing? Mesh renderer. Okay. All right. Okay, so we usually create a mesh object that we will put our mesh data into, and then finally assign that mesh object to the mesh filter that we just created. So let's create a mesh object. Mesh equals new mesh. Okay, pretty simple. And then we're going to go mesh dot vertices, and mesh has the same kind of array that we created above there. So we'll just set the vertices array of the mesh object to equal the vertices array that we created earlier. Okay, and we'll do the same thing for the triangles. Mesh dot triangles equals triangles, and that's it for our mesh. So let's assign our mesh to the mesh filter. So we want to go mesh filter dot shared mesh equals mesh. And we just need to do one final thing, which is to add a texture to our mesh renderer. So let's go back into our Unity project out the way. Okay, so in our materials folder, we'll I've got one there called red. Could use that. I'll just create a new one for the sake of it, for the sake of demonstration. And in our materials folder, we will create a new material, and we'll call that blue matte. And we'll just set the base ambient color to something bluish. Alright, that'll do fine. Alright, so it's blue matte. Alright, so we'll just come back into our script and we'll add public material mesh matte, and we can assign that in the editor, but don't need to do that in here. And the last thing we'll do is mesh renderer dot material equals mesh matte. Okay, and I think, wait a second, why does this thing think there's a bunch of issues? Okay, so just fix that. You can initialize the array like this, but you need that syntax. Okay, no errors now, so we'll save that and we'll go back into Unity. Give that a second to finish compiling. Alright, now we'll just make a empty game object to put that onto, that script. We'll call this my mesh. And we'll add the component, add the script my mesh to that, and if we hit play we should see our square, hopefully, fingers crossed. And there it is. Only trouble is we've got the, well, as you can see, it's facing the right way because it's visible from the front. Only thing is we've got the purple texture of death, and why is that? That is because if we look at our script here, we've got to assign the material, so just drag that in. And now it should be nice and blue, no longer purple. Alright, all working correctly as advertised. And if we just go to wireframe mode, actually we'll go to shaded wireframe, you can actually see that it's it's not a square as such. It is composed of two triangles, the same way that the triangles in that dolphin were. Alright, so that brings us to the end of this little tutorial. Once you can do things like creating a mesh like this, you can just about do anything you like. In fact, let's just jump back into some of our vertices here. So the first vertex, instead of starting that at x equals 0, let's start it at x equals -1. Just looking at these. So that's going to pull that back that way. And let's pull this one over this way, and we'll get a, what do you call that thing, trapezoid. So vertex number 1 is going to be at x equals 2. Save that. Jump back into Unity. See what happens now. Yep, we've got our trapezoid. I'll just turn the line off. Alright. So once you're able to do that, you can start moving vertices in different directions, like, I don't know, let's say two of these vertices, the last two have a z coordinate of 2. Then we're going to move things not just purely to be in the xy plane anymore. See what happens this time. Alright, if we zoom around it, you can see that it's no longer just in the xy plane, it's being tilted. So yeah, as I was saying, once you can make triangles, and once you can make this kind of system where you can construct vertices and triangles as integer arrays, which are indices into this, which are sort of references to these indices here. Once you can do that, and these basic manipulations here, you can create whatever you like dynamically. Alright, I just thought I'd add on to the end of this video too, a little bit more about what you can do with this stuff once you've built on what we've just done. So this is inside a game I'm working on, and this is a game where the entire world is made of meshes which are procedurally generated. So actually I'll turn the directional light on, and you can see all of this mesh here, and there's a lot more in other parts. It's all created dynamically, procedurally. Right. It's a bit hard to see it, but yeah. Okay. Alright, so if you learned something from this video, please give it a like. And if you think you want to stick around and get notifications of my new videos, please hit subscribe. I really appreciate that. It does help a lot. Alright, thanks guys. See you for now. Bye.